A razor blade cannot slide between the stones of certain ancient walls. This is the mystery of seamless megalithic joints, and by the end of this video, you will understand exactly how ancient builders achieved this impossible precision with only simple tools. We will uncover how they shaped granite with sand and water, and why some of their methods still puzzle modern engineers. What does it truly take to build something that lasts for thousands of years? That impossible precision is not just a trick of the eye. Run your hand across the surface of a wall at Sacsayhuaman, and you feel the truth of it. The stones are not uniform rectangles. They are a chaotic puzzle of polygonal shapes, each one unique, with multiple sides and strange angles. Yet every single face of every single block fits perfectly against its neighbor. This is the essence of the seamless megalithic joint. There is no mortar, no glue, no filler substance to hide the mistakes. The entire structural integrity comes from the flawless contact between two custom-shaped pieces of granite or limestone. Think of it like a three-dimensional jigsaw puzzle carved from stone weighing many tons, where the gap between pieces is often thinner than a single sheet of paper. Archaeologist Jean-Pierre Protzen spent years at these sites, and his observations reveal something profound. The contact surfaces are not flat. They are subtly curved or slightly undulating, creating a powerful interlocking effect that resists earthquakes and the relentless pull of time. This tells us their goal was not simply to stack rocks. They were creating a unified, monolithic entity from countless individual parts. To grasp how they did this, we must first look more closely at the raw material itself and the hidden clues left within the stone. These ancient builders were masters of their material long before a single stone was ever cut. They walked the mountainsides with a deep, intuitive understanding of the living rock, searching for the perfect candidate. This was not a random selection. They sought out specific types of stone, granite or limestone, with the ideal blend of hardness for durability and a manageable grain size for shaping. Their primary goal was to find stone that would resist the elements for millennia, yet still be workable with the simple tools at their disposal. The quarry itself was a testament to this profound knowledge. Look at a site like Ollantaytambo, where massive, partially extracted blocks remain frozen in the cliff face. They reveal a critical secret. The builders did not fight against the mountain. Instead, they learned to read it, identifying natural fracture lines and planes of weakness within the stone. They would then employ a remarkably simple yet effective technique. Workers would carve a series of holes along a predetermined line, inserting dry wooden wedges into them. Then they would pour water over the wood. As the wedges absorbed the water, they swelled with immense gradual pressure, coaxing the stone to split cleanly along its own natural fault. It was a patient dialogue with the geology, not a violent assault. How could they possibly identify the best materials without modern geological surveys? Theirs was an empirical science, a knowledge system refined over countless generations. They learned to read the color, the texture, the sound a rock made when struck, and the way water flowed over its surface. The land was their open book, and they understood its language fluently. This careful, deliberate selection of the raw stone was the indispensable first step. It set the stage for the next, even more precise phase of the work, transforming a rough-hewn block into a perfectly fitted puzzle piece. Once the raw stone was split from the mountain, the real transformation began. Picture a master craftsperson seated before a massive granite block, a simple hammerstone in hand. This was the art of pecking, the foundational technique for shaping the impossible. There was no rushing this process. The artisan would strike the stone's surface again and again, not with brute force, but with a controlled, rhythmic tapping. Each impact would crush a tiny grain of the crystalline structure, slowly, incrementally wearing the surface down. It was a conversation between the worker and the material, a patient removal of minuscule fragments over countless hours. The goal was not to shatter the stone, but to persuade it into a new form, one precise peck at a time. After the basic shape was achieved through this relentless pecking, the next stage of refinement would begin. The builders would take abrasive sand, often a harder quartz material, mix it with water, and use a flat stone or a piece of leather to rub this slurry across the surface. This grinding action acted like a prehistoric sandpaper, polishing the contact faces to an incredible degree of smoothness. Experimental archaeologists have shown that these two methods, pecking and grinding, are entirely sufficient to create the flawless surfaces seen on ancient Egyptian granite sarcophagi. The joints are so tight that they seem to be a single piece of stone. What kind of mindset does this demand? It requires a profound dedication, a perspective where time itself is a tool. This was not a job for a single lifetime, but a legacy project where an artisan's patient work would contribute to a structure meant to endure for millennia. This hands-on mastery of stone provided the perfect foundation for the next, even more ingenious step in the process, the method that allowed them to fit these massive blocks together with such breathtaking accuracy. But the pecking and grinding only created the smooth surfaces. The true genius of these joints lies in how they were aligned. A second, more subtle technique reveals itself upon close inspection. Incising and grooving for alignment was the master key. Imagine a sculptor carefully scoring fine lines onto a stone block to guide its final form. This is precisely what ancient builders did. They used durable stone or even copper chisels to cut shallow grooves and reference marks directly onto the rock faces. These were not decorations. They were a functional blueprint, a system of registration marks designed to ensure perfect alignment during the monumental task of assembly. At the Coricancha temple in Cusco, if you look closely at the sacred walls, you can still see the faint ghost lines of these incisions. They hint at a meticulous, deliberate planning phase that happened long before the final, thunderous placement of a multi-ton block. How did they maintain such incredible consistency across dozens of unique, irregular blocks? The grooves acted as a physical guide. Workers could test fit blocks against one another, checking how the marks lined up. This allowed for minor, incremental adjustments through additional pecking and grinding, a process of trial and error until the fit was absolutely perfect. It was a step-by-step method that transformed an impossibly complex puzzle into a manageable, repeatable process. This attention to detail shows us that their precision was not magical. It was the result of a systematic, patient approach where every cut, every groove was a calculated move in a much larger game. This careful preparation on the ground was essential, but it leads to an even greater question. How did they actually move these perfectly shaped stones into their final, impossible positions? Even the most precisely pecked stone requires a final, transformative touch. The third technique, abrasive sand polishing, was the ultimate refinement. Think of workers placing two stone surfaces together, but with a crucial intermediary, a wet slurry of sand and water. They would then rub the stones back and forth, or use a flat stone tool to work the abrasive mix across the surface in a slow, deliberate motion. This was not a quick process. It was a patient, grinding dance that could last for days or even weeks on a single face. Each pass of the abrasive slurry acted like a microscopic chisel, wearing down the highest points on the stone's surface, gradually, inexorably, creating a flatter and flatter plane. The choice of sand was a science in itself. Builders selected naturally occurring sands with specific grits, often favoring hard quartz crystals over softer materials. They understood that a coarser sand could remove material more quickly for initial shaping, while a finer, almost powdery grit was essential for achieving the final, nearly flawless finish. This entire process bears a striking resemblance to a modern machining technique called lapping, where two surfaces are rubbed together with an abrasive to achieve near-perfect flatness. The results of this ancient method are breathtaking. Look at the andesite and basalt blocks at Puma Punku in Bolivia. Some of their surfaces are so incredibly smooth that they reflect light like a dull mirror, a testament to countless hours of meticulous hand polishing. How did they ensure such uniformity across a surface wider than a person is tall? It likely involved the use of long, straight reference stones or wooden beams, checking for gaps and high spots repeatedly throughout the painstaking process. This was the final step in transforming a rough-shaped block into a precision component. It demonstrates a profound truth that relentless friction and human persistence could achieve a level of perfection we now associate with powerful machinery. But this creates a new and compelling question. Once you have a collection of these perfectly polished, impossibly shaped stones, how do you possibly assemble them into a wall that defies a razor blade? Beyond the patient work of hammerstones and grinding sand lies a more dramatic force of nature. These builders did not just shape stone with their hands, they learned to command the elements themselves. One of the most compelling, though debated, methods involves the strategic use of fire and water. Imagine applying intense heat from a controlled fire directly to a granite surface, then dousing the superheated rock with cold water. The sudden, violent contraction from thermal shock could cause the stone to fracture along its crystalline boundaries. This was not a wild, uncontrolled burn. It was a precise application of thermal stress, a way to make the incredibly hard material more brittle and easier to work. In certain quarries, faint scorch marks on rock faces hint at this experimental practice, a testament to ancient engineers testing the limits of their materials. The risks were immense. An uncontrolled crack could ruin a block worth months of labor. Yet the potential reward, a method to split and shape stone with dramatically reduced physical effort, must have been an irresistible challenge. Alongside fire, water was a powerful ally in its own right. We have already seen how soaked wooden wedges could split stone in quarries, but this same hydraulic principle could be applied on a smaller, more delicate scale for fine adjustments. Workers might drill a line of small holes, insert dry wooden pegs, and then soak them. The swelling wood would generate immense directional pressure, potentially flaking off a thin, precise layer of stone to perfect a joint surface. Harnessing these elemental forces reveals a sophisticated, almost intuitive grasp of physics. They were not just artisans, they were early material scientists, manipulating the fundamental properties of rock with fire and water. This innovative spirit leads us to the final, and perhaps most mysterious, piece of the puzzle. How did they coordinate all these techniques to assemble a structure that has stood firm for thousands of years? The stone itself becomes the lock and key. Across the world, from the Cyclopean walls of Mycenae to the sacred structures of Peru, ancient builders engineered a solution that went far beyond flat surfaces, crafting blocks that physically gripped one another. This is the mystery of interlocking shapes, a technique that transformed a wall from a stack of stones into a single, unified mass. Instead of simple rectangles, they carved a chaotic-looking jigsaw puzzle of polygonal blocks, each with multiple sides and angles. Each unique stone was designed with subtle protrusions called bosses that fit snugly into corresponding recesses on its neighbor. This created a powerful three-dimensional lock that resisted shifting from any direction. The primary force this design countered was not just gravity, but the violent lateral shaking of earthquakes. In a region like the Mediterranean, prone to seismic activity, a rigid wall of uniform blocks would be vulnerable. But an interlocking polygonal wall could absorb and dissipate that energy, allowing the stones to shift and settle without collapsing. The entire structure could move as a flexible, living entity. How could they possibly plan such an intricate, non-repeating pattern without modern blueprints or computer models? The answer likely lies in a form of template-based planning. Master builders may have used scaled models or marked out full-size patterns on the ground, a method some researchers call a giant's drawing board. Each block's identity was not defined in isolation, but in relation to the stones already in place. The process was one of constant feedback, test-fitting a block, noting the high spots, and patiently pecking them away until the fit was perfect. This required an extraordinary kind of spatial reasoning, an ability to visualize complex negative spaces in 3 dimensions. The builders were not just stacking rocks, they were solving a dynamic, weighty puzzle where every new piece changed the context for the next. This geometric ingenuity forces us to look deeper, to the invisible principles of mathematics and proportion that guided their hands. The final step in this epic process was perhaps the most dramatic. After countless hours of shaping and polishing, the perfectly fitted stone had to be raised into its exact position, a task requiring more than just muscle. Envision teams of workers surrounding a multi-ton block, their simple tools poised for a delicate ballet of force and control. Long, sturdy wooden levers were the primary instruments. By placing a lever under a stone's edge and using a fulcrum, a small group could lift one side of the massive weight, allowing others to slip stones or wooden cribbing underneath. Inch by inch, they could walk the block upward, a patient process of lifting, propping, and resetting the levers. This leverage system gave them the fine control needed not just to lift, but to rotate and minutely adjust the stone's angle, ensuring the meticulously crafted joints met with flawless contact. For even greater stability and to reduce the immense physical strain, builders may have employed counterweights. Imagine large bags filled with sand or baskets of smaller stones, suspended from ropes over a simple frame. As a block was levered up on one side, a counterweight descending on the other could help balance the load, making the operation safer and more manageable. The placement of the massive lintels atop the upright stones at Stonehenge almost certainly relied on such principles. They had to raise these crosspieces high into the air and then lower them with absolute precision onto their weighting supports, a feat impossible through brute force alone. What does this tell us about their society? It reveals a highly organized, collaborative effort. Coordinating these operations required clear communication, trusted leadership, and a shared understanding of physics. A single misstep could shatter months of painstaking work. The use of these simple machines, levers, and counterweights highlights the genius of ancient engineering. They found ways to amplify human strength, to translate coordinated effort into impossible precision. This final act of assembly was the ultimate test of their planning and skill, bridging the gap between the solitary craft of shaping and the communal triumph of construction. It forces us to reconsider the very definition of technology, moving beyond the tools themselves to the sophisticated knowledge systems that guided their use. Stone itself has a voice, and the ancient builders learned its language. In the final moments of fitting 2 massive blocks together, they employed a technique that required no eyes, only ears and a deep, intuitive touch. A worker would take a stone mallet and gently tap on the surface of a newly placed block, listening intently to the sound that echoed back. This was acoustic testing, a sensory science of resonance. A clean, sharp ring or a unified, deep thud indicated that the contact between the stones was seamless, with no air gaps to disrupt the vibration. A hollow, dull sound, however, was a clear signal of a void, a hidden pocket where the surfaces were not meeting perfectly. This immediate auditory feedback allowed for precise, on-the-spot adjustments. Workers could then mark the high spot, patiently pecking and grinding until the stone sang the correct note. This method is not just ancient history, it is a practice still used by traditional stonemasons today, a living echo of that old knowledge. Inside the Serapeum of Saqqara, the colossal granite boxes, each weighing many tons, stand as a testament to this fine-tuning. Their polished surfaces are not just visually perfect, they resonate with a uniform, profound tone when struck, suggesting the builders achieved a harmony of contact that transcends our visual understanding. How could such an abstract concept become a standardized tool? This required a generational transfer of skill, where master craftsmen taught apprentices to recognize the specific sounds of a perfect fit. It was a knowledge held not in books, but in the trained ears and hands of the artisans. This auditory dimension reveals a craftsman who was not just a sculptor, but a musician, using the resonance of stone as his final tuning instrument. This multi-sensory mastery brings us to the ultimate question, one that looks beyond the how and asks the more profound why. What drove this relentless pursuit of perfection in the dark, where no human eye would ever see the result? The walls of Cusco curve and flow like a single, petrified river of stone. Here, the Inca mastery of polygonal masonry reaches its zenith, with blocks of every conceivable size and shape merging into seamless surfaces that challenge our very understanding of construction. Each stone is a unique individual, yet it is part of a unified whole, fitted to its neighbors with such precision that the joints seem to disappear. This was not a haphazard pile of rocks. It was a deliberate, engineered system designed for survival in a land shaken by powerful earthquakes. The secret to its resilience lies in the very irregularity of the pattern. When the ground shakes, a rigid wall of uniform blocks is vulnerable. But this interlocking polygonal web can shift and settle, absorbing the violent energy without collapsing. The entire structure moves as a single, flexible entity, settling back into place once the tremor has passed. How could such an intricate, non-repeating puzzle be assembled without a master blueprint? The process was one of patient, iterative shaping. A massive block would be rough-shaped at the quarry, then dragged to the building site. There, the real work began. Stonemasons would slowly, meticulously, adjust the block's many faces to fit the negative space left by the stones already in place. They used the simple pecking and grinding techniques we discussed, test fitting the stone again and again, shaving off tiny high spots until the fit was absolutely perfect. This was a dynamic, three-dimensional puzzle solved in real time. To guide this incredibly complex process, master builders likely used small clay models or physical templates. These were not detailed architectural plans, but rather conceptual guides that established the overall form and critical angles. They provided a reference point, a way to visualize the final relationship between stones, while still allowing for the necessary on-site customization for each unique block. This blend of overarching design and adaptive craftsmanship reveals a culture that viewed engineering as a living, responsive art. The sheer scale of this labor-intensive work across the entire Inca Empire speaks to a highly organized society. Coordinating the quarries, the transport, and the armies of skilled artisans required immense social cohesion and a shared vision. Their stonework is more than just a technical achievement. It is a physical manifestation of their worldview, a culture that understood how to integrate human ambition with the enduring strength of the mountain itself. This legacy of seamless joints forces us to confront a profound question about the nature of their knowledge. Were these methods purely the result of generations of trial and error, or did they arise from a deeper, more intuitive understanding of the hidden forces that shape our world? Granite is one of the hardest stones on Earth, yet the ancient Egyptians treated it like soft wood. Their work on colossal obelisks and the intricate sarcophagi found deep within pyramids presents a different kind of precision, one defined by flawless geometry. Where the walls of Peru are an organic, interlocking puzzle, Egyptian stonework showcases a mastery of perfect planes, sharp right angles, and impossibly smooth surfaces. This was not a flexible, earthquake-resistant design, but a pursuit of absolute, monumental permanence. To achieve this, they developed a specialized toolkit for conquering granite. They used dolerite, a stone even harder than granite, as hammerstones to pound and shape the rough blocks. For cutting, they employed a simple yet devastatingly effective invention, the copper saw. But the copper itself was too soft to scratch the granite. Their genius was in the intermediary. They used abrasive sand, constantly fed into the cut. The saw's action simply dragged the sharp quartz crystals across the granite surface, letting the sand do the actual cutting through relentless, patient friction. The evidence for this is etched into history. Examine a partially cut granite block from an ancient quarry, and you can still see the straight, deep grooves left by this slow, grinding process. For drilling, their methods were even more ingenious. They used tubular drills likely made from hollow copper pipe. Again, they would use an abrasive sand slurry, turning the drill back and forth under pressure. This technique ground away a circular channel, leaving behind a solid core of stone in the middle. The cores themselves have been found, and the inside of the drill holes often show faint spiral markings, a permanent record of each individual grinding stroke made thousands of years ago. This method allowed them to create perfectly circular holes with an efficiency that stuns modern engineers. But how did they ensure such perfect flatness and square angles across a sarcophagus larger than a car? The surfaces in the king's chamber of the Great Pyramid provide the answer. The granite walls there are so precisely flat and the corners so perfectly square that they imply the use of sophisticated measuring tools. They almost certainly used taut, coated cords to check for straightness, leaving a fine line as a guide. For checking planes, they might have used a flat reference stone of known accuracy, dusting it with ochre or soot and pressing it against the surface, the transferred pigment revealing any high spots that needed further grinding. This level of quality control required more than skilled labor. It demanded rigorous mathematical planning and a hierarchical system of oversight. A master builder would have checked every critical measurement, ensuring that every component fit the grand design. How did they maintain this unwavering standard for decades on a single project? The answer lies in a culture that embedded precision into its very worldview. Their perseverance was not merely physical, it was an intellectual and spiritual commitment to creating a perfect, eternal vessel, a testament to their belief in an everlasting order. This Egyptian benchmark in granite work stands as a powerful reminder that systematic methods and an unwavering dedication to process can overcome even the most formidable material challenges. The Lion Gate of Mycenae stands as a silent, formidable guardian. Its massive limestone blocks are so perfectly joined they appear to have been poured into place rather than carved. This is the power of Cyclopean masonry, a style defined by colossal, irregular stones fitted together with breathtaking care. The Mycenaean builders understood that true strength did not come from uniformity, but from a deliberate chaos of shapes. Each multi-angled block was a unique piece in a giant's puzzle, its interlocking form creating a wall that could not be pulled apart. The builders achieved this by focusing their immense effort not on the entire stone, but on the critical contact points where one block met another. Using the same patient techniques of pounding with hard hammerstones and grinding with abrasive sand, they worked these specific surfaces until they achieved a seamless fit. The rest of the stone could remain rough and unshaped, a testament to their efficient, brilliant prioritization of structural integrity over superficial finish. How did they lift and maneuver these colossal weights into such precise positions? The strategic use of earthen ramps and stout wooden levers allowed them to nudge each block into its final resting place, making microscopic adjustments until the fit was locked in. These walls were more than just fortifications, they were a statement of power and permanence, a physical manifestation of a culture's strength. The very name Cyclopean, from the belief that only the mythical one-eyed giants could have moved such stones, reveals the awe they inspired. Their enduring legacy, standing strong for over 3,000 years, forces us to look beyond the Mediterranean. it invites a comparison with another legendary tradition of stone, one that flourished on an entirely different continent, yet achieved a similar, impossible perfection. Hidden within the apparent chaos of these stone puzzles is a silent, mathematical order. The seamless joints and interlocking angles were not achieved by chance or by eye alone. They were guided by an underlying framework of sacred geometry and standardized proportional systems. Builders worked with geometric ratios like the golden section or the simple, stable proportions of root rectangles. These were not abstract concepts but practical tools. A master might use a knotted cord or a set of wooden rods to physically lay out these ratios on the ground, establishing the key angles and dimensions for a block before a single hammerstone ever struck. This systematic approach ensured that even uniquely shaped stones shared a common, harmonious language of proportion, allowing them to fit together logically and create a structure of immense integrity. Look at the foundational layout of the Giza Plateau, where the positions of the pyramids and their internal chambers reflect a profound understanding of geometric principles. This was not mere decoration, it was functional engineering. A block carved to a specific angle based on a root 2 rectangle, for instance, would naturally possess greater stability and lock more securely into its neighboring stone. How were these sophisticated mathematical concepts passed down through generations without a written language? The knowledge was likely embedded in the tools and the rituals of the craft. The measuring cord itself, the set of standard rods, the repeated patterns practiced by apprentices, these became the living repositories of geometric truth. This reveals a hidden layer of intellectual planning behind what might otherwise look like brute force construction. The flawless stonework is a testament to a culture that saw number and form as the fundamental building blocks of reality itself. This mathematical foundation provided the invisible blueprint, but it raises a final, compelling question about the minds that conceived it. What deeper understanding of the world allowed them to see the hidden geometry in a mountain and translate it into a wall that has defied time itself? The theoretical blueprint of ancient methods finds its ultimate test in the dusty, sun-baked quarries of experimental archaeology. Here, modern researchers trade their textbooks for hammerstones, attempting to replicate the seamless joints using only the primitive tools the ancients had. This is not a thought experiment, it is a physical, grueling dialogue with the stone itself. At sites like Ollantaytambo, teams have dedicated weeks to shaping a single block of andesite. Their toolkit is starkly simple, heavy stone hammers for the initial rough work, smaller, precise hammerstones for pecking, and baskets of abrasive sand mixed with water. The goal is not to prove they can do it faster, but to understand the process from the inside out, to feel the same blisters and frustrations, and ultimately the same triumphs. These hands-on trials have yielded a profound insight. The precision is not in the tool, but in the technique. A skilled worker learns the exact angle and force needed for each strike, how to read the stone's grain, and when to switch from pounding to grinding. The resulting joints, while taking hundreds of hours to create, can indeed achieve that legendary paper-thin fit. This empirical work reveals the immense human cost behind the perfection. It was not a mysterious secret that made it possible, but an overwhelming investment of coordinated labor and patient, accumulated skill. By physically engaging with the materials, researchers gain a deep empathy for the ancient artisans. They understand the auditory feedback of a good strike, the visual cue of a changing surface texture, and the sheer physical endurance required. This bridges a critical gap between abstract theory and tangible practice, turning historical hypotheses into validated, repeatable processes. It confirms that the methods we have discussed are not just plausible, they are demonstrably effective when applied with the right knowledge and unwavering dedication. The stone itself speaks of the land it came from. In Egypt, the abundance of soft limestone and hard granite led to a dual approach, using one to build the great masses of the pyramids and the other to craft the eternal vessels within. The dense, crystalline nature of granite demanded the patient, abrasive sawing techniques we see reflected in the flawless sarcophagi. Meanwhile, in the Andes, the prevalence of andesite, a volcanic stone with a more forgiving granular structure, made the meticulous pecking and grinding of polygonal walls a practical, if laborious, endeavor. The very rock under their feet directed the evolution of their methods, proving that the first and most important tool was a deep familiarity with local geology. This relationship with the material world was deeply entwined with spiritual beliefs. The Inca concept of Pachamama, or Earth Mother, likely infused their construction with a profound respect. To them, shaping stone was not an act of conquest, but a form of reverence, a way of honoring the living spirit of the mountain by carefully reassembling its pieces into a new, harmonious form. Their walls were not built upon the land, but were woven into its fabric. Similarly, the Egyptian drive for geometric perfection in their granite tombs was not merely an engineering goal. It was a spiritual imperative, a belief that a perfect, eternal vessel was necessary for the soul's journey beyond. Cultural values directly dictated the purpose of the precision. Environmental pressures further sculpted these architectural philosophies. In the seismically active Andes, the threat of earthquakes was a constant, brutal teacher. The solution was the flexible, interlocking polygonal wall, a design born from the necessity of survival. Each irregular joint was an answer to the ground's violent tremors, allowing the structure to shift and settle without collapse. In colder climates, the relentless cycle of freezing and thawing could shatter rigid stonework. This challenge may have spurred builders in other regions to develop even tighter joints to minimize water infiltration, turning a climatic threat into an innovation for durability. How did these external factors foster such unique solutions? They forced a dialogue. Each civilization was answering a different set of questions posed by its environment, its resources, and its gods. The seamless joint, therefore, is not a single secret to be uncovered, but a family of brilliant adaptations. It represents a holistic response to a unique set of conditions, connecting the cold, hard stone directly to the warm, beating heart of the culture that shaped it. Such theories of otherworldly architects carry a powerful allure. It is a captivating story, one that suggests our own history is not enough to explain these wonders. Yet this narrative, while imaginative, overlooks the profound evidence of human ingenuity etched into the stone itself. The archaeological record tells a very different story, not of sudden, miraculous intervention, but of gradual, painstaking progress. We can trace the evolution of stoneworking techniques over centuries, from simple, rough-hewn structures to the breathtaking precision of the later monuments. Each generation of builders stood on the shoulders of the last, refining their methods through endless cycles of trial and error. The so-called impossible precision is only impossible if we ignore the thousands of years of accumulated knowledge that preceded it. Why do these myths persist so stubbornly in the face of such clear, physical evidence? They speak to a deep-seated desire for mystery, a romantic notion that the past holds magical secrets lost to time. But in reaching for the stars to explain these achievements, we inadvertently diminish the very real and far more impressive genius of ancient human cultures. We rob them of their legacy. The true marvel is not that aliens might have built these walls, but that people did, with nothing more than patient observation, relentless experimentation, and an intimate connection to the materials of their world. By focusing on the factual techniques, the pecking, the grinding, the acoustic testing, we do more than just solve a historical puzzle. We pay respect to the true architects, the countless anonymous hands and minds who transformed a mountain into a monument, and in doing so, left behind a permanent testament to what humanity can accomplish. This grounded understanding invites a final, broader reflection on what this knowledge means for us today. That same precision which has defied millennia now whispers to modern architects and engineers. The seamless megalithic joint is no longer just a historical curiosity. It is a source of profound inspiration for how we build our own future. In an era dominated by steel and concrete, the ancient art of dry stone construction is experiencing a quiet renaissance. This method, which uses gravity and friction instead of manufactured cement, offers a powerful model for sustainable building. It eliminates the immense carbon footprint of cement production and creates structures that are naturally breathable, adaptable, and ultimately recyclable, as the stones can simply be returned to the landscape. This is not a step backward, but a step toward resilience, drawing on a timeless wisdom that understood harmony with the environment long before the term was coined. The ancient principle of interlocking forms is being reimagined in cutting-edge, earthquake-resistant designs. Just as the polygonal walls of Cusco could sway and settle during a tremor, modern engineers are developing structural systems that allow buildings to flex and absorb seismic energy rather than fighting it. The concept of modular construction, where prefabricated components snap together with exacting accuracy, directly echoes the way those massive, custom-shaped blocks were fitted. It is a marriage of ancient logic and digital precision, proving that the fundamental ideas of weight distribution and geometric locking are as valid today as they were 4,000 years ago. What does this tell us about the nature of true innovation? It suggests that sometimes the most forward-thinking solution is hidden in the distant past. Perhaps the most humbling legacy is the reminder of what human hands and patience can achieve. In a world racing toward full automation, the flawless work of these ancient artisans stands as a testament to the irreplaceable value of deep, skill-based craftsmanship. Their work was not about speed, it was about permanence. Each perfectly placed stone speaks of a culture that invested in the long term, that valued the mastery of a material over the quick completion of a task. This challenges our modern metrics of efficiency. Is a building truly efficient if it lasts for 50 years or one that stands for 5,000? Their endurance asks us to reconsider our own priorities, to blend the incredible power of modern technology with the timeless virtues of care, precision, and foresight. The stones themselves pose the ultimate question: what are we building that will truly last? A master craftsperson's toolkit was deceptively simple, a curated collection of nature's own offerings. The most fundamental tool was the hammerstone, a dense river cobble gripped in a calloused hand. Builders maintained a range of these stones, from large, heavy ones for the initial rough work to smaller, precise ones for delicate pecking. The choice of material was critical. A dolerite hammerstone was essential for working granite, while a softer stone could be used on limestone. For reaching into tight angles and undercuts, they employed picks made from the sturdy tines of deer or elk antlers, leveraging the natural strength and resilience of bone. When a fine line or a shallow groove was needed for alignment, a copper or bronze chisel, painstakingly cast and hardened, was the instrument of choice. The manufacturing of these metal tools was a craft in itself, requiring controlled smelting and careful hammering to create a durable edge. Maintaining a sharp, effective point on a soft copper chisel meant constant resharpening and careful use to avoid bending or blunting it against the unyielding stone. Beyond the striking tools lay the true agents of perfection, the abrasives. Quartz sand, harder than most construction stones, was the essential ingredient. It was gathered, sorted by grit size, and mixed with water to form a grinding slurry. This simple paste, applied with a flat stone or a piece of leather, acted as a transformative polishing agent, capable of wearing down granite over time. For the monumental task of moving these shaped blocks, the toolkit expanded to include simple machines. Wooden sledges, likely lubricated with water or mud, slid over tracks of logs. These rollers, positioned and repositioned by teams of workers, turned impossible weight into manageable momentum. Even the elements were co-opted into service. We have seen how water-swollen wood could split stone, and how fire could be used to thermally shock surfaces for easier working. Each implement, from a fist-sized hammerstone to a sprawling log roller, was an extension of the builder's will. How did they know which tool to use for each specific task? This knowledge was not written down, but lived in the hands and minds of the artisans, passed from one generation to the next through years of apprenticeship. The true sophistication was not in the complexity of the tools, but in the deep, intuitive understanding of how to apply them. This versatile, earth-born toolkit challenges our very definition of technology, suggesting that ingenuity can flourish with the humblest of materials. Behind every seamless joint was a lifetime of learning. A young apprentice did not simply pick up a hammerstone. He entered into a long, silent conversation with the master craftsperson. Skills were not taught from a book but transmitted through careful observation and countless hours of guided practice. A novice would spend years on simple tasks, learning to feel the right amount of force for a strike, to listen for the true ring of a solid fit, and to recognize the subtle texture of a surface ready for its final polish. This was an education of the hands and the ears, where knowledge was stored in muscle memory and the shared experience of the work itself. The master's guidance ensured that the precise techniques for pecking, grinding, and fitting were preserved and refined with each new generation, creating an unbroken chain of expertise that could span centuries. How could such intricate knowledge be maintained without a single written manual? The answer lies in the power of oral tradition and immersive, hands-on training. The workshop was the classroom, and the stone was the only textbook they ever needed. This deep, personal cultivation of skill was the essential foundation, but it was only one part of a much larger social machine. The sheer scale of labor required to build a site like Sacsayhuamán or to raise an Egyptian obelisk is almost beyond our modern comprehension. This was not the work of a solitary genius or a small team. It was a monumental, community-wide endeavor that required the coordinated effort of thousands. Historians note that these projects were often seasonal, aligned with the agricultural calendar, drawing on a vast workforce of farmers during times when the fields were fallow. This was not forced labor in the grim sense we might imagine, but a collective social and religious duty. The construction of a temple or a sacred tomb was an act that benefited the entire community, strengthening its bond with the gods and ensuring its legacy for the future. The work itself became a form of social glue, a shared purpose that transcended individual hardship. How did they organize such a massive undertaking without modern management systems? Society was structured to support these projects, with a clear hierarchy of overseers, architects, and team leaders who translated the master plan into actionable tasks for the workers. Food, water, and shelter had to be supplied for this army of laborers, a logistical feat that speaks to a highly organized and motivated society. The motivation was not solely practical. These structures held profound spiritual and cultural meaning. To contribute one's labor was to participate in a grand, cosmic order, to leave a personal mark on something eternal. This shared purpose fostered an incredible culture of discipline and patience. The mindset required was not that of a modern construction crew racing against a deadline. It was the patience of geology itself, a slow, deliberate persistence where a project might take decades, or even the reign of several kings, to complete. This long-term perspective cultivated a standard of excellence where there was no room for the quick and easy fix. A worker knew that his small, perfect joint would be hidden for millennia, yet he made it flawless for the gods, for his community, and for the silent judgment of time. The seamless fit, therefore, is more than a technical marvel. It is a physical imprint of human cooperation, a testament to what can be achieved when an entire culture aligns itself toward a single, enduring goal. The earliest stone walls were rough assemblies of fieldstone, stacked with gaps filled by smaller rocks. This was the Neolithic beginning, a practical solution for shelter and enclosure long before the pursuit of perfection. At sites like Skara Brae in Scotland or the earliest layers of Jericho, the priority was stability, not seamless contact. The joints were wide, the surfaces uneven, and the structures relied on their own low, sprawling weight and simple gravity to hold together. The builders worked with what was readily available, using stones that could be moved by hand or with simple levers, their methods shaped by immediate necessity rather than a vision for the ages. Yet within these humble beginnings, the essential principles were already present: the understanding of a stable base, the interlocking of irregular shapes, and the gradual refinement of technique through trial and error. What sparked the shift from this functional stacking to the obsessive precision of later eras? The evolution was not a straight line but a slow, branching journey across continents. In Mesopotamia, the rise of city-states and organized religion created a demand for monumental architecture, for ziggurats and temples that reached for the heavens. This social and spiritual ambition pushed builders to develop more refined methods, working with cut stone and mud mortar to achieve greater scale and grandeur. In Egypt, the early mastaba tombs, simple rectangular structures of mud brick and rough stone, gradually gave way to the stepped pyramid of Djoser, a revolutionary structure that showcased the first large-scale use of cut stone. Here, the joints are still visible, the blocks are smaller, and the methods are clearly in their formative stages. Each project served as a living laboratory, a place where artisans could test new ideas, learn from failures, and slowly accumulate a body of practical knowledge. This knowledge became a cultural inheritance, passed down and refined over centuries until it culminated in the flawless granite geometry of the Great Pyramid. The drive was a complex mix of the practical and the profound. Competition between rising powers certainly played a role, as kings and pharaohs sought to outbuild their rivals with ever more impressive monuments. But the spiritual demand for permanence, for creating an eternal home for the divine or the deceased, was an equally powerful motivator. A poorly fitted stone in a burial chamber was not just an engineering flaw, it was a spiritual risk, a potential breach in the vessel of eternity. This chronological view reframes the peak achievements we so admire. The seamless walls of the Inca or the perfect sarcophagi of the Egyptians were not sudden miracles. They were the hard-won pinnacle of a 1,000-year-long conversation with stone, a cumulative triumph of human observation, patience, and the relentless desire to build something that would outlast the generations. The stone itself was their first and most patient teacher. Ancient builders possessed an intimate, almost instinctual understanding of material science, a knowledge forged not in laboratories but through generations of direct physical interaction with the living rock. They learned to read a stone's biography in its color, its texture, and the sound it made when struck. A clear, ringing tone signaled a dense, flawless internal structure, ideal for bearing immense weight. A dull thud might indicate hidden fractures or weaknesses, warning them to select a different block. This was an empirical science, a deep catalogue of experience passed from master to apprentice, detailing how each type of stone would behave under the hammer, during shaping, and across centuries of exposure. They knew that granite, while brutally hard, had a crystalline structure that could be patiently abraded away with quartz sand. Softer limestone, on the other hand, was more easily carved with stone tools but required greater protection from the elements. This practical wisdom allowed them to match the material to the mission, choosing the right stone for the right purpose with unerring accuracy. Their most critical skill was identifying and working with a stone's natural cleavage planes and grain direction. Just as a modern carpenter splits wood along its grain, These builders learned to split colossal boulders by finding the path of least resistance within the stone itself. At the quarry, they would meticulously trace these invisible lines, then employ their simple but brilliant technique of drilling holes and swelling wooden wedges. The stone would not shatter randomly, it would separate cleanly along its own predetermined weakness, saving incalculable time and effort. This was not a fight against the material, it was a collaboration. How did they accumulate such a sophisticated understanding without formal geology? Their knowledge was embodied, held in the muscles and senses. A craftsperson would spend a lifetime feeling the feedback of a hammerstone, learning exactly how much force to apply to a specific type of granite, or how the angle of a strike could flake away a perfect sliver from a piece of limestone. They understood how stones would settle under their own immense weight, how different minerals would weather over time, and how to orient a block to maximize its inherent strength. This deep, intuitive familiarity with their material was the silent, essential foundation for every seamless joint. It allowed them to predict how the stone would behave not just during construction, but for 1,000 years thereafter. This profound material wisdom leads us to a final, unifying principle, a concept that ties all these techniques together into a single, elegant system of thought. A seamless joint was a prayer made solid. For these ancient builders, the perfect fusion of stone was far more than an engineering feat. It was a physical echo of their deepest spiritual convictions. In cultures from the Andes to the Nile, the cosmos was understood as a vast, harmonious system, a perfectly interlocking whole where every element had its place. A wall built with invisible joints was a human-made mirror of this divine order, a small piece of the universe rendered in stone according to its true, flawless principles. The relentless pursuit of perfection was not just about durability, it was a form of devotion, an attempt to align human creation with cosmic law. How else could we understand the motivation to polish a surface that would be buried forever, or to fit stones with impossible precision on a cliff face where no one would ever see it? The act of building was itself a sacred ritual. For the Inca, the very act of shaping and fitting stone was a way of honoring Pachamama, the Earth Mother. They were not extracting a dead resource, they were carefully rearranging the living bones of the sacred mountain, weaving its essence into a new form that maintained its spiritual integrity. Each perfectly locked block symbolized the unbreakable bond between the people, their ancestors, and the land itself. The structure was not simply built upon the earth, it was an extension of the earth, and its seamless joints were the proof of that respectful relationship. The Egyptian approach, while different in style, sprang from a similar philosophical wellspring. Their drive for geometric perfection in a royal tomb was a spiritual imperative. A flawless granite sarcophagus was not just a container, it was an eternal vessel for the soul, a perfect, unbreachable form that mirrored the unchanging order of the heavens. Any gap, any flaw was a potential rupture in that cosmic protection, a risk to the soul's journey into the afterlife. This symbolic weight transformed the stonemason's work from a trade into a sacred duty. The anonymous artisan pecking away at a block for months understood that his labor contributed to something far greater than himself, a project that touched the divine. This profound symbolic dimension answers the question of why. Why invest such staggering amounts of time and labor when a simpler, good enough wall would have sufficed for centuries? The answer lies in the realm of meaning. The seamless joint was a cultural statement, a declaration that their world was built on principles of harmony, unity, and eternal order. The stones themselves were messengers, and their silent, perfect language spoke of a universe where everything fits together. Even the most skilled artisans faced a world of constraints. Their profound understanding of stone and friction could not overcome every physical limitation. Certain types of rock, like exceptionally hard basalt or emerald-rich quartzite, resisted even their most patient methods. Shaping these materials with simple hammerstones and sand would have demanded a staggering, almost unimaginable investment of time, making large-scale projects from such stone practically unthinkable. This material barrier directly influenced their architectural choices, leading builders to select more workable stones like limestone or andesite for their grandest visions. The sheer size of blocks was another formidable boundary. While they moved colossal weights, there was a practical ceiling. Transporting and placing a block beyond a certain mass, perhaps over 200 tons, likely pushed the very limits of their logistics, lever systems, and the strength of their ropes. How did these limitations shape their designs? They fostered a deep intelligence of compromise. Architects learned to use gigantic foundation stones for stability, while constructing upper levels with smaller, more manageable blocks. This pragmatic approach reveals a sophisticated balancing act between ambition and the possible. Without modern optical tools, maintaining absolute precision across a vast facade was another challenge. A wall 100 meters long might show minute variations in alignment, deviations invisible to the naked eye but measurable today. This was not a failure of skill, but a testament to the human scale of their work. They achieved perfection one joint at a time, even if the grandest scale introduced tiny human imperfections. Recognizing these boundaries does not diminish their legacy. Instead, it grounds our awe in reality. Their genius lies not in defying physics, but in mastering everything within their reach, turning inherent limitations into a catalyst for some of the most resilient and enduring structures ever built. A world apart, the stonemasons of Easter Island and the sculptors of ancient Egypt never met, yet their hands followed the same path. The colossal moai statues, carved from volcanic tuff, bear the same telltale marks of patient abrasive polishing as the granite colossi of Luxor. This is not a coincidence, but a powerful example of convergent evolution in human technology. When faced with the universal challenge of shaping hard stone to a fine finish, isolated cultures independently discovered that rubbing an abrasive sand slurry across the surface was the most effective solution. It was a simple, elegant answer to a common problem, emerging again and again across the globe. The same principle applies to the interlocking polygonal walls found in places as diverse as Peru, Greece, and Japan. Without any shared blueprints, builders on different continents realized that a wall made of uniquely shaped, tightly fitted blocks could withstand earthquakes and the passage of time far better than a stack of uniform rectangles. They each arrived at the idea that strength comes from a flexible, unified mass, not from rigid, individual parts. What does this pattern reveal about the human mind? It suggests that our intelligence is fundamentally tool-based and solution-oriented. When presented with similar materials and similar challenges, our species has a remarkable tendency to converge on similar, highly effective answers. The pecking of stone with a harder hammerstone, the grinding with sand, the use of levers and ramps, these are not secrets belonging to one culture, but rather the shared inheritance of human ingenuity. This global perspective transforms our understanding. It shows that the seamless joint is not an isolated mystery, but a widespread testament to a universal human drive to build with permanence and precision. This recognition of our collective heritage invites a humbling thought that the same innovative spirit that shaped an Egyptian obelisk also guided the hands that raised the moai, connecting humanity across vast oceans and centuries through the silent, enduring language of stone. The silent perfection of these ancient walls now faces a relentless modern challenge. Preservation teams work as guardians, meticulously monitoring the structural stability of sites like Machu Picchu, where the very seams of the stone are threatened by erosion and the subtle, constant pressure of the earth itself. Their task is a delicate balance, an ethical commitment to minimal intervention. The goal is never to rebuild or replace, but to stabilize and protect, using compatible materials that honor the original construction without mimicking it. This philosophy ensures that every stone, every weathered surface, retains its authentic voice, telling a true story of its age and journey. Yet the greatest threats are often the most visible. Millions of footsteps each year, the gentle brush of countless hands, and even the moisture from human breath contribute to a slow, cumulative wear on surfaces that have endured for millennia. How can we balance the public's right to experience these wonders with the absolute necessity of their long-term survival? The answer lies in careful management, from limiting daily visitor numbers to constructing viewing platforms that protect the most fragile joints from direct contact. Environmental changes add another layer of complexity. Increasingly severe weather patterns can accelerate erosion, while ground shifting from heavier rains can subtly stress the very foundations of these monuments. The work of conservation, therefore, is a race against time and a changing world. It is a global responsibility, an effort that ensures the legacy of the ancient builders is not lost. The care we take today is more than technical maintenance. It is a profound act of respect. It honors the original intent and breathtaking craftsmanship of those anonymous artisans, guaranteeing that their silent lessons in patience, precision, and harmony will continue to inspire generations yet to come. The seamless joints we have explored are more than a historical puzzle solved. They are a mirror reflecting the core of human potential. These ancient builders did not possess magic or alien technology. They wielded something far more powerful, an unwavering patience and a profound dialogue with the natural world. Their legacy is not locked away in a lost secret, but is written plainly in the language of pecking marks, polished surfaces, and interlocking angles. It is a story of how ordinary people, using simple tools and extraordinary minds, achieved the impossible. They teach us that true innovation is not always about creating something new, but about perfecting the relationship between our hands, our materials, and our time. Every stone in these ancient walls carries the memory of that skill, a silent testament to the enduring power of human collaboration and vision. Let this journey change how you see the world. The next time you stand before an ancient structure, look past its age and see the intelligence in its seams. Each perfect joint is a message from the past, reminding us of what we are capable of when we build with purpose and care. If this exploration into humanity's shared architectural heritage resonated with you, we would love to hear your reflections in the comments. For more deep dives into the mysteries our ancestors left behind, subscribe and join us on the next adventure. The greatest lessons are not always found in books but etched in stone, waiting for us to read